step, you arrange in ascending order, you have to explain where is actually the locations of 28. So, I hope you still remember, this is what we actually learned based on the diagram. I will have a total of 100% to refer to total number of data. Q2 eventually will be separate the data into 15% each to the left hand side, right hand side. This is your Q2. Okay? And your Q1 and Q3 will be both separating this 50% of the data into equal part as well. So your Q1 is referring to this black color, and you will actually separate into 25% each if you are referring to the data that you have. Same thing goes to here. Your Q3 is here, so you will have a 25% on the left, 25% on the right. So where is actually my positions of 28? Your number 28 is actually here, which is the second value in the arrangement. Indirectly, you also can say that this number 28 falls at the first 25% of the data. Alright? Your number 28 actually falls in the first 25% of the data. Alright? Or you can actually say that this data is actually within the first quartile and so on. Okay? But I would suggest you to write this way. 28 actually lies in the first 25% of the data which arranged in ascending order. 28 lies in the first 25% of the data which arranged in ascending order. Okay, so next we will go to IQR. So part B, when we are calculating IQR, it's just as usual. Your IQR interquartile range going to calculate based on Q3 minus Q1. So will be my 49 minus 37. So you will get your answer is 12. Oh, sorry, 30.5. So you should get 18.5 as the IQR answer. Now correct? Should be Q3 minus Q1, right? IQR. Q3 is 49, right? Am I right? Yes, what is the problem? Any problem with the answer? Oh, no problem. So what is the problem of processing and Soha? Okay, if no problem, that means now we will proceed to the next part. Next, we will go to example number 37. This is also under ungrouped data, but it's an ungrouped frequency distribution. Alright? So what we are going to do here, we need to start with finding Q1, Q2, Q3. That means position very important. Go and find your position. But when you actually given in ungrouped frequency distribution, you need to refer to the cumulative frequency. Alright? So please help me to calculate the cumulative frequency first. You add on a lines, columns behind the second column. You calculate cumulative frequency for me. So your cumulative frequency should be 4, 12, 23, 28 and 30. 1, 2, 3, 4, 5. You have 5 different numbers here. Okay, so we will start from what? Starting from position of Q2. This is still ungrouped data, is ungrouped frequency distribution. Okay, so we'll start with position of Q2. So when you calculate positions of Q2, must be still using n plus 1 divided by 2 because it's an ungrouped data. So your n plus 1 divided by 2, n for your reference must be referring to the total frequency that you have because it's an ungrouped frequency distribution. Alright? Your frequency, total frequency will be representing total number of data that I have. So my positions of Q2 will be automatically become 30 plus 1 divided by 2. And you will get 15.5. Okay. So can you please tell me 15.5? If you refer to the cumulative frequency, we should refer to which row? When we refer cumulative frequency of 15.5 must fall under which row? First one, second one, third one, fourth one, or fifth one? 15.5 must be in the third row. Okay? 15.5 must be in the third row. Okay, so now, what do you understand about the positions of 15.5? When you talk about positions of 15.5, it's actually telling you this 15.5 must be in between data number 15 and also data number 16. Do you agree? Yes? Yes, good. So my Q2 value must be data number 15 plus data number 16 divided by 2. Because 15.5 is exactly in the middle between data 15 and 16. Alright? So data number 15 must be data number 9. Data number 16 also referring to data number 9 divided by 2, and you get answer is 9, Q2. Okay? For ungrouped frequency distribution, we will actually do it this way. Okay? That means you have to write up, this one is for your reference, which data and which data is actually involved. If you don't want to calculate your answer in this way, you have another way. That means you list down the number 7777 4 times. 8, you have to write 8 times and then you do the cutting, but will be very messy. Okay? Next, we go to position of Q1. Okay, we go to position of Q1. If we try to illustrate the situation in this way, this one, everybody listen carefully. If you actually can understand this, for those group who are actually doing the last semester paper, you can actually do if you understand this. Alright? Okay, so let's say now I try to convert all these informations into here. My Q2 actually is equals to 9. The position is 15.5. Okay, the position is 15.5. Please tell me, on the left hand side of Q2, you have how many data? You have to use your imagination now. Position of Q2 is 15.5, means this cutting line is cutting in between data 15 and 16. So now, my question, if you already cut this position for your Q2, your left hand side will consist of how many data? 15. Right hand side, you have how many data? 15 as well. Why? Because Q2 basically separate the data into 2 equal parts. If you have 15 data on the left, definitely you will have 15 data on the right. Until here clear? Yes. So now, positions of Q1 will be calculated using n plus 1 divided by 2. But this n value is going to focus on the total number of data on the left hand side. So your left hand side, you have 15 data. Therefore, this will be 15 plus 1 divided by 2, and you are expected to get the 8 data. So your 8 data, you have to referring to the cumulative frequency lah. It's actually under which group lah. Okay. So your Q1 will be referring to data number 8. Your data number 8 actually falls under the second row. Therefore, your Q1 value is what? What is your Q1 answer? 8. Okay? Same thing now. We are going into position of Q3. When we go under this position of Q3, you are actually using the same position as Q1. We'll be actually referring to the 8 data, but must be from the back. Okay? In this case, I actually do not have left hand side, right hand side, so I'll just write from the back. Okay? So, how do you actually identify data number 8 from the last one? So, you can actually just write a cumulative frequency for your reference. Now, we are no longer talking about smallest to biggest. Now, we reverse. Okay? Now, we reverse. The cumulative frequency starting from the last data, you will have 2, you will have 7, you will have 18, 26, and also 13. Your data number 8 calculated from the back. Data number 8 calculated from the back must be in the third row as well. Okay? So therefore, your Q3 answer will be the same with the data value of the third row, which is value 9. Answer. Okay? For repeat student, some of you actually holding the old notes. If you are holding the old notes, they will actually have a formula for you to do calculation. For your information, if you are using that formula to calculate, your answer will be totally different from whatever I calculate. You will have decimal value answer sometimes. Refer to different cases, different answer. That's why I do not use the formula while I'm actually teaching when I go to this ungrouped frequency distribution. Alright? Okay, so far until here, everybody still can survive? Still can understand? Ungrouped data, we already covered 2. You have raw data, you have to arrange first, and then you do cutting, find the position. But after that, we go to ungrouped frequency distribution, where we keep on comparing the cumulative frequency. Alright? Now, based on this slide, you are going into the difficult part, which is the group frequency distribution. That means now, when we are dealing with group data, alright, how do you calculate the value of Q1, Q2, and Q3? Every time when they give you group data, your life becomes difficult. Formula become very difficult as well. For your information, this formula will not be provided in your test or final exam while finding quartiles of group data. But you can realize something. If let's say I ask you to refer to this formula, directly look at this formula, don't think so much, you can actually relate this formula to what? You will actually find that this formula is exactly the same thing with median formula. This formula is exactly the same thing with the median formula, but only one term is different. This term different. All these terms, n divided by 4, n divided by 2, 3n divided by 4, are referring to the positions of Q1, Q2, and Q3. That means no matter how, when you are performing or calculating the value of quartiles for group data, we still have to go and find the positions of Q1, where is Q1? Position of Q2, where is Q2, and so on. After using these informations, apply this position into the formula to calculate the value of quartiles. Okay? So let's see what do we have here. When you want to find position of Q1 for group data, will be n divided by 4. Alright? If you want to find position of Q2 for group data, will be n divided by 2 as usual. Alright? When you calculate position of Q3, will be 3n divided by 4. Okay? That means it's actually the what we call quarters lah. Okay, the calculation is actually related to your quarters. Alright, so n divided by 4, n divided by 2 and 3n divided by 4 for the position. Then when we calculate, we'll be using this formula. You need to understand what are actually the terms referring to. If you have LQ is still referring to the lower boundary, but lower boundary of the Q1 class, lower boundary of the Q2 class, lower boundary of the Q3 class. C is still referring to your class width of the Q1 class width of the Q2 class width of the Q3 class. Alright? Small f is referring to the frequency. FQ, frequency of Q1 class, frequency of Q2 class, frequency of Q3 class. All these terms are the position. That means after you calculate, you substitute directly. Summation of FQ minus 1 is the cumulative frequency before the Q1 class, before the Q2 class, and before the Q3 class. Cumulative frequency before the Q1 class, cumulative frequency before Q2 class, cumulative frequency before Q3 class. All these are actually the information that you know when you are dealing with all these terms. Alright? So, I will do step by step in terms of calculating your Q1, Q2, and Q3 referring to this data. No need to worry so much. If you can understand, that means directly you can get the idea already. Okay? So, we will start with this. We need cumulative frequency as a reference, so you should actually have 3, 7, 12, 18, and 20. This cumulative frequency is going to help us to find or identify Q1 class, Q2 class, and also Q3 class. Alright, so we go for position of Q1. Your position of Q1 going to calculate based on n divided by 4 term. So in this case, your n is referring to the total frequency. Total frequency is 20. So it will be 20 divided by 4, and you should get the fifth. Okay? When you're referring to the fifth, that means compared with the cumulative frequency, fifth is actually under the second category of the second class. Therefore, my Q1 class will be 63 to 65. That is your Q1 class. Okay? Next, after you already identify your Q1 class, the next part will be identifying the data, whether it's a discrete group data or continuous group data first. Because when you find a lower boundary, you will know the shortcut. So this is what we call the discrete group data. Therefore, my lower boundary must be in 0.5 form. Alright? So if you are talking about this, your LQ, okay? Your LQ, lower boundary of the Q1 class, referring to this, will be 62.5. Okay? Will be 62.5. Next, we will go to CQ. CQ is the class width of the Q1 class. Class width of the Q1 class will be 65.5 minus 62.5 to give you 3. Alright? FQ, frequency of Q1 class will be 4. Okay? Position of Q1 n divided by 4 will be actually 5. We will actually plug it into the formula later on. And summation of FQ minus 1. Cumulative frequency before the Q1 class. Before the Q1 class is 3. So our Q1 calculation Q1 is equals to LQ plus with CQ divided by FQ n divided by 4 minus summation of FQ minus 1. Okay, that is my formula. So you should have 62.5 plus with 3 divided by 4, 5 minus 3. You should get Q1 64. Is this your answer for Q1? Please help me to check, alright? Okay, next we go to Q2. We will start with position of Q2. Just in case you need the formula, later you can refer on the slide. Position of Q2, you are going to calculate using n divided by 2 pH term. Alright? So you should have 20 divided by 2 and we'll be referring to the 10th frequency. So referring to the cumulative frequency, your 10th frequency or 10th data must be referring to the third class. So my Q2 class will be starting from 66 to 68. Okay? Once again, we are going to list down the information. You need to have LQ, you need to have CQ, FQ, and summation of FQ minus 1. Alright? LQ value, lower boundary of the Q2 class will be 65.5 because you have a discrete group data. So it's just lower limit minus 0.5. CQ class width will be 68.5 minus 65.5, you're getting 3. Next, your FQ. Your FQ is the frequency of the Q2 class, will be actually 5, correct? Yes. Summation of FQ minus 1, cumulative frequency before the Q2 class will be 7. So, my Q2, going to calculate using LQ plus CQ over FQ. N divided by 2 minus summation of FQ minus 1. Okay, so my LQ 65.5 plus with 3 over 5, 10 minus 7. 1.8, 67.3. That will be my Q2 value. Alright? Okay, so referring to this pattern, please proceed with calculating Q3. Later I will discuss. Everybody calculate Q3 for me, follow the same thing. Alright? Identify the positions of Q3 and find out which one is your Q3 class. After that, list down the information and plug in directly. Hey, what happened? You want to give me answer or? Yes, my friend, what you want? Cannot, I still rushing for my syllabus. Later, my class will continue 2:30. Before 2:30, you come in. That means 2:25. So now you go and walk first. 2:25, you come back. Yeah. Okay, bye bye. Valentine's Day, I know you want flower, but syllabus more important. Faster, faster, huh? Position of Q3. Good. 3n minus 4, 3n divided by 4. So you should have 15. So your Q3 class is how much? 69 to 71. LQ, lower boundary of the first quartile class, Q1 class will be 68.5. Okay, your CQ will be 71.5 minus 68.5 and you get 3. Frequency of the Q3 class, you get 6. Cumulative frequency before that, you give you 12. Okay, suppose I believe most of you should be able to list down all these informations. So now we are going to substitute the informations one by one. 68.5 plus with 3 divided by 6. 3n minus 4 will be 15 minus 12. Okay, so 9 over 6 is 1.5, you get 70 exactly. Okay, so that will be my value of Q3. Some students will ask, sir, during test, during final exam, really have to write so much math? No need. If during test, during final exam, you can directly provide this part, actually can already. All this is because of what? During lecture, I want everybody to understand. You know how to list out all the values already. Alright? Now we go to example 39. Compute the weight K that is exceeded by 20% of the adult. Okay. So you need to understand what the questions actually ask you. Normally, I will come up with a simple number line first for your reference. Alright? I come up with a simple number line for your reference. This is what they meant. This is what they meant. You have a number line. Of course, you have a value of K. This is actually a K. You will have 20% of the adult exceeded this K value. So that means 20% of the adult more than this K value. This part will be 20% of the data. This part will be 80% of the data. Until here, any problem? No. So now, your job is to find the value of K, but when you calculate this value of K, you can refer to this quartile formula to actually help you. But you are no longer talking about the same positions to do the calculation. You have to calculate position of K. Alright? So we now going to start with the first step, finding position of K. Your position of K must be actually located for this part, focusing on 80% of the data. You have total data of 20, total frequency is 20, but multiply with 80%. So you will find that the value of K will actually fall under this 80%. So you will have 16 positions. Okay, that is our first step. First step is to actually find the position of K, where this position of K, we are going to use total frequency 20, okay? Total frequency 20 multiplied by 80%. So you should actually get the position, the last line of the 80%, alright? So, when you're actually referring to this part, your position is 16, referring to the cumulative frequency to find where is 16, alright? 16 actually must fall under the last second class, 69 to 71. So K class, 69 to 71. So when we are going to calculate the value of K, K value is going to calculate based on the quartile formula. Based on the quartile formula will be the lower boundary of the K class, okay, plus with class width of the K class divided by frequency of the K class, multiply with position of K, minus cumulative frequency of the K class before the K class. So basically, even though the formula fixed to actually use the symbol of Q, but all these formula can be actually modified by yourself. Okay? So your LK, lower boundary of the K class will be 68.5. Okay? Your CK will be 71.5 minus 68.5, you get 3. Your FK, frequency of the K class. Frequency of the K class will be actually following the fourth one, will be 6. Cumulative frequency before the K class, okay, will be 12. So, substitute into your formula, you should get 68.5 plus with 3 divided by 6, multiply position of K is 16, position of K is 16, minus 12. So you should get 412 to 70.5. That will be the value referring to the value of K. Okay? So this example, you might need to use more time to actually understand. For your information, this kind of question actually is quite popular. Okay, it's quite popular. Instead of asking you to find Q1, Q3, Q2, and Q3 directly, they might choose any positions for you to actually calculate. So when this kind of situation happens, you need to find the positions of the unknown by referring to whatever we have here, alright, according to the proportions that we have. Then use the quartile formula to calculate the value of K. Adjust the formula or the terms one by one accordingly. Alright? So now we finished calculating the quartiles. So there will be one more graph for us to study. There will be one more graph, so that means I'm expecting everybody have a graph paper also. Alright? So let's see what we have. We are going to discuss box plot. Box plot means that later on when you draw the diagram, you must have a rectangular shape to represent the box. Okay? But in fact, a more proper name to actually explain this box plot will be box and whisker plot. Alright? So in your box plot, you will actually have minimum 2 components. You have box, you have whisker. If let's say for doing your calculation, you found that there's any outlier, you need to include outlier in your calculations of the graph as well. Okay? We will look into that. Don't worry about the drawing first. We will draw after 2:30. So I'm now going to brief you the theory part. Okay? While drawing your box plot, these are the information that you need. Alright? You need to have smallest value, largest value, Q1, Q2, Q3 value, and lower fence and upper fence. These are the 7 informations that you need to include in your box plot. Alright? So, for your information, when we are actually talking about this box plot, most of the time we are actually doing or related to your ungrouped data. That means if let's say you have group data, they normally do not really ask you to draw box plot. Box plot normally applies in ungrouped data like raw data, ungrouped frequency distribution. Alright? Mostly it's these 2 situations. So when you have ungrouped data, definitely you should be able to identify what is the biggest value of the data and the smallest value of the data. That's why they actually include here smallest and biggest observation. Q1, Q2, Q3 value will be referring to Q1, Q2, Q3 that you actually find from ungrouped data. That means you need to find the position of Q2, n plus 1 divided by 2. Then after that, you find Q1. Q1 is also the median of the data on the left-hand side and so on. Understand the idea, the flow, how to find Q1, Q2, and Q3. Lower fence and upper fence basically is 2 values or 2 barriers to help you identify the outlier. As long as you found that in your calculations, any data value bigger than upper fence or any data value smaller than lower fence, that particular data will be automatically considered as a quartile. Alright? But of course later on we will actually have a slide to actually show you how to do calculations of that, how do you actually look into this to identify the outlier. So no need to worry for the moment. Next slide will be actually telling you, next two slides, you will have two ways to draw your box plot, but normally my style, if I give you two options, normally I will restrict to become one. So you can actually either draw your box plot horizontally, alright? But of course the scale is going to put at the bottom now. This is actually just the reference that we find from the book's main textbook, alright? When we draw a box plot, my scale at the bottom, then your box plot is actually above the scale. Or you can actually draw in this way. Your scale is actually vertically from the smallest to the biggest, from the bottom to the top. After that, we are going to draw our box plot from here, smallest value to the biggest value. Alright? But usually our practice, I will not ask you to draw this. So you just need to emphasize in this part. Alright? So later when we go into example, this is what we are going to draw. Okay. So, what they are trying to tell you here, they are trying to tell you or ask you understand what is box and whisker. So, if let's say we are taking this as our focus of the box plot, your box will be here. Box will be referring to this rectangular size box. This rectangular size box is going to draw based on Q1 value, Q2 value, Q3 value. So, every time when you draw your box plot, the first thing is to directly draw the lines representing Q1, Q2, and Q3. After you draw the lines, use your ruler to connect to form a box. This will be the box. Whisker is referring to this part. This is what we call the left whisker. This is what we call the right whisker. This whisker is going to draw starting exactly in the middle of Q1, middle of Q3, directly connect to the smallest value, connect to the biggest value. Alright? So smallest value we will also draw a vertical line to represent, and biggest value we will also draw a vertical line to actually represent that particular data. Alright? So the whisker, what is actually usage of whisker? Whisker actually managed to display the range of the data. Okay, when we talk about range, meaning it's just like smallest is which value to the biggest is which value. Okay? It's just to describe the range of the data. Okay, next slide. By the way, box plot also can help us to identify the distributions of the data. When we talk about distributions of data, we'll be referring to what? Referring to symmetric distribution, skew to the left, skew to the right. So we will actually look into every cases here. Alright, what is the conditions to fulfill so that you can actually classify them into either one of the category. If you are talking about symmetric distribution, you have to make sure left box and right box. That means the distance from Q1 to Q2, distance from Q2 to Q3 must be the same distance. The gap must be the same. If Q1, Q2 is 10 units, then Q2 to Q3 also have to be 10 units. That is the first condition. Next, we'll be talking about the whisker. If you talk about whisker, must be the same length as well. Meaning, starting from this position, middle of Q1 to the smallest value, how big is the gap? From Q3 to the biggest value, how big is the gap? This distance, this gap must be exactly the same. So for symmetric distribution, they must fulfill two things. Alright? Box must be equally distributed, and also whisker, the length must be exactly the same. Okay? But when we are talking about skewed to the right, more curvy on the right hand side, tail is longer on the right hand side, when we refer to the box plot, you should be able to identify the patterns. Okay. You should be able to identify the patterns in order to classify as skewed to the right. You see, right hand side whisker is longer. And the box on the right hand side is also bigger than the left hand side. So when you say about skewed to the right hand side whisker must be longer, and the box on the right hand side, meaning from Q2 to Q3, must be actually bigger than Q1 to Q2. Alright? If you talk about skew to the left, tail is longer on the left, your whisker on the left hand side must be longer, and the box on the left hand side is also bigger in terms of size. Okay? So you see, in terms of writing, normally this is how we write for the reason, in terms of describing the box. If you are talking about this gap, the size of the left-hand side box, we'll be talking about Q2 minus Q1. Because we want to ensure the calculation, the value that we get is a positive value. We always use big number minus the small number. So Q2 minus Q1 must be bigger than Q3 minus Q2 in this case. Alright? If you talk about this, Q3 minus Q2 must be bigger than Q2 minus Q1 and so on. Okay? Okay. Next. 1, 2, 3, 4. Okay. Next, we'll be talking your lower fence and upper fence. This lower fence, upper fence basically is a barrier to help you to check whether your data exceeds any outlier. Your lower fence and upper fence calculation is going to be these two formula. Wait, no formula meh? No formula lah. Then you write up. Okay. Okay, your lower fence calculation is going to be Q1, starting from the first quartile Q1, minus 1.5 IQR. Your upper fence calculation is going to be Q3 plus 1.5 IQR. Okay? So after you actually calculate this value, you have to compare with the data that you have. If you found that any data value is bigger than this answer, then that data will be actually become an outlier. If you found that any of the data is smaller than the lower fence answer, then that particular data will be your outlier as well. Okay? So, I will continue after the break. Okay, I will continue after the break. We will go into the examples and teach you how to actually draw the box plot when you have no outlier and with outlier. Okay? So for the moment, during the break, if you want to go and find out which of you is actually under the same group, then you can just go ahead or refer to my attendance list. You know, I already do the grouping of your group assignment and which questions you have to do for every group. You all check WPLE, okay? So you go and find out who is actually your group member.